Assalamualaikum and salam sejahtera. My name is Muhammad Afizuddin bin Sulaiman. Matric number DD200005. We are from Group 3, Section 4, and our title is Line Balancing at Tealive Parit Raja, Johor. So our team consists of 5 members, which are Muhammad Noizuddin bin Osman, Muhammad Afizuddin bin Sulaiman, Muhammad Darwish Abidin bin Zainal Abidin, Luqman Hakim bin Hilman, and Muhammad Rafael bin Muhammad bin Mat Fazuleh. For introduction, line balancing involves determining the optimal number of workstations, the required operating time for each station, department placement, and the distribution of tasks within each station. In other words, it is a method to identify the most efficient way to ensure a smooth workflow. Attaining the objectives of line balancing will allow for increase in production without disruptions while preserving the morale of workers. These methods also allow timing system to regulate average time, determining the time required by a skilled worker while operating at a specific level. For problem statement, Tealive Parit Raja are having trouble to achieve the sales for the according month, which is about 3,000 to 4,000 pieces of foods and drinks. Second one is the workers' workflow are making it difficult to deliver the foods and drinks to the customers on time. Objective of the study: using line balancing to increase the line efficiency. Second one is to reduce and organize the amount of workstation required. And the last one is reducing labor in order to produce the necessary quantity of units daily at an appropriate cycle time. Scope of the study: focusing on the Tealive production line. The assembly line efficiency will be the main focus, and the line balancing procedure will increase the line efficiency.
So I will be talking about literature review. So in this literature review, we have three categories. First one is assembly line balancing and problem. Second is assembly line balancing methods, which is exact and heuristic. And the last one is methodistic methods. So for assembly line balancing and problem, we have Baker and Associate in 2006 an overview of the issues and solution related to generalized assembly line balance was given. Traditional and still appealing methods of mass and large scale series production include assembly lines. In recent times, a great deal of research has been conducted to characterize and resolve more practical generalized challenges. In his work on cost-oriented assembly lines, Mr. Amin took into account upper and lower bounds, model formulation and solution. Dimitris in 2006 said the work was presented on assembly line balancing and group working. A heuristic procedure for workers group operating on the same product and workstation. In this work, they examine an assembly line problem that differs from the conventional one. So for assembly line balancing methods, in the first one, MEN 2000, an overview of cost-oriented assembly line balancing heuristic approach was given. The primary emphasis of this effort was assembly line balance with a cost orientation. This issue mostly arises in the final assembly of consumer durables, personal computers, and automobiles, where labor-intensive production methods are still used and wages are determined by skills and credentials needed to complete the job. Secondly is Gene and Associate 2002 publication of a new heuristic approach to be mixed model assembly line balance problem. For the mixed model assembly lines problem, a common GIT system approach called the goal chasing method was presented. So for majoristic method, a multi-objective genetic algorithm is proposed in Ponabalam 2000 papers. A multi-objective genetic algorithm for solving assembly lines balancing problem to address assembly line balancing issues. 2007, Bautista additionally add an algorithm were created to solve an assembly line between a problem with time and space constraints. In conclusion, the suggested algorithm validity was examined by a computational experiment using reference cases. So for the methodology, the organization of machine capacity is a layout to ensure a reasonably uniform flow at capacity operation is known as line balancing. It is a layout with equal operation time for each of the process subsequent operations. The goal of line balancing is to reduce the amount of excess inventory while matching the manufacturing output rate to the production schedule, allowing for on-time delivery. Line balancing is necessary for product planning since an unbalanced production line might result in inefficient use of machinery. So there are three methods of line balancing. The first one is increasing output. Is the first and the most obvious step in the right way. Secondly, is a further approach is to send a second product close to the first one, allowing the some ideal equipment to be employed in tandem. Thirdly is estimating the output of the last workstation, which may be thought of as the lowest production of all intermediate workstation, is the final option. So these are the steps in line balancing. The first one is to draw the precedence diagram. Secondly is to calculate the cycle time, which is cycle time equals to available times divided by desired output. Thirdly is assign tasks to the workstation. So number of workstation equal to summation of task time divided by desired actual time. Last but not least is to determine the line efficiency, which is line efficiency is equal to sum of task times divided by number of workstation multiply the desired cycle time.
I will continue the presentation with the result and analysis part. As you can see, there are two tables of data that we obtain from our site visit at Tealive Malaysia. The first table gives us the work processes for drink, and the second table gives us work processes for food. And the time taken was seconds for both work processes. The total operation time is 12 hours per day, and the target production is 3,500 units per day for both processes. And our result analysis will discuss the line cycle time, the efficiency for both processes, and the precedence diagram for both processes. To calculate the line cycle time, C, for both processes, we must determine the output ratio, which is R. Since the target production is 3,500 pieces per day for both drinks and food, we must divide 3,500 by 2. So 3,500 divided by 2 equals to 1,750 pieces per day. And the output ratio, R, is determined by dividing the operation time with the target production. So R equals to 1,750 pieces per day divided by 12 equals to 145.83 pieces per hour. From that equation, we can calculate the line cycle time for both processes. Since the output ratio for both processes are the same, so we just calculate it one time. The line cycle time C is 1 over R. Then 1 over 145.83 equals to 6.85 times 10 to the power of negative 3 hour per pieces. And since our data obtained was in seconds, so we must convert the line cycle time into seconds per pieces, seconds per unit. Then 6.85 times 10 to the power of negative 3 hours per pieces multiply 3,600 seconds per hour. And that gives us a total of 24 seconds per pieces. That is our line cycle time. The efficiency is different for both processes because the calculation is based on the total time taken for each work element, line cycle time, and the theoretical minimum number of workstations. In that case, we will start with drink processing. The total time taken is 150 seconds, and the number of workstation is total of time taken divided by line cycle time, which is 150 seconds over 24 and that gives us a total of 6.25. And for workstation, we'll take it as 7 workstations. And the efficiency is total of time divided by number of workstation multiply the line cycle time multiply 100%. So the equation is 150 seconds over 7 workstation multiply 24 seconds per unit multiply 100%, and that gives us a efficiency of 89.29%. The calculation for efficiency for food process is the same as drink process, but the data is different. So the total time taken for food process is 920 seconds. And to find the number of workstations, the total of time taken divided by line cycle time, which is 920 seconds divided by 24 equals to 38.22, and that gives us total of 39 workstations. For the efficiency, total of time taken divided by number of workstation multiply line cycle time and multiply 100%. 920 seconds divided by 39 workstations multiply 24 seconds per unit and multiply 100%. That gives us a total of 98.3% efficiency for food process. This is the precedence diagram for drink processes. It has a total of 8 work elements. The first work element A has no predecessor, so it will start first. The work element B and C, its predecessor is from work element A. Work element G is predecessor from work element C, and work element H is predecessor from work element G. As for work element D, its predecessor from work element B. Work element E is predecessor from work element D, and lastly, for work element F, its predecessor from work element E. Thus, this is the whole precedence diagram for the drink processes. This is the precedence diagram for food process. The total work element for food process is 6 work elements, which is work element A, B, C, D, E, and F. For work element A, it has no predecessor, so it will start first. For work element B, the predecessor is work element A. For work element C and D, the predecessor is B. And for work element E, it has 3 predecessor, which is work element B, work element C, and work element D. And lastly, for work element F, its predecessor is from work element E.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rafael. So now I will continue with my part, which is discussion and suggestion. Okay. Line balancing is an important part of operation management that tries to improve efficiency and productivity by equally allocating workload among workstations. Line balancing is critical in a fast-paced environment like Tealive, where customer pleasure and service quality are important. This chapter will dig into the topic of line balance and how it might be improved in Tealive. Okay, now we move to the next part for the drilling process. Based on our result, I summarize into the table, which is line efficiency equal to 89.29%, number of workstation is 7, and line cycle time is 24 seconds per pieces. Okay, in the drilling preparation step, when efficiency is critical to meeting consumer expectation, then line balance is critical. Tealive balances the workload among its barista by standardizing drink recipe, optimizing equipment architecture, and offering clear instruction for duty distribution. This led barista to operate in unison, ensuring that each cup is produced swiftly and precisely. Based on the result gain, the efficiency percentage is like I say, 89.29%, which means the ideal time for barista to prepare the drink are lower than 90%. That can give high impact on customer satisfaction because of the time to make a cup of drink take much time. So in this case, the working time are influenced by the barista itself because they only provide one barista in drink section. So that can be the limitation for this study, but still under control and satisfaction. Now for the recommendation, in order to improve or minimize the waiting hour for the customer, Tealive should determine the optimal number of barista required during peak and non-peak hours. This approach ensures that customers are served promptly, reducing wait times and enhancing the overall customer experience. Furthermore, periodic assessment of workstation layout also required to ensure that physical arrangements support efficient workflow because it can prevent congestion and bottlenecks, contributing to a smoother production process. Next part is for the food process. You can see the data from the table. Line balancing holds significant importance in food preparation. It involves distributing tasks and responsibility among different station or kitchen staff to optimize efficiency. Efficiency refers to the process of optimizing customer waiting time and maintain a high level of service quality. From the result above, the line efficiency for food preparation are better than the drink preparation in tea life. This is because of the ideal workstation in the premises, which is the space are much bigger than drink section and the layout are more flexible. Okay, for the last part, which is recommendation for the food process. In this case, the premise should rearrange the layout of the workstation, make the barista section as flexible as food preparation station. This can ensure the balance on the working time to barista and the food handler. Next, in conclusion, line balancing plays a vital role in optimizing the efficiency and effectiveness of food preparation and drink preparation. It ensures that resources are used intelligently, jobs are assigned correctly, and the premise runs smoothly in order to satisfy consumer expectation. This benefits the firm not just operationally but also positively influence consumer views and loyalty. That's all from me. Thank you.
Okay, I will continue for the conclusion. We can conclude that the major goals of this project were met throughout the process based on our experience and data analysis that we analyzed, gained, and discovered. We selected to apply line balancing as the focus of our project after learning about it in our industrial engineering lessons, which is one of the reasons we were able to accomplish the desired output rate with the fewest number of workstations at Tealive, Malaysia. This helped maintain a smooth and continuous flow of production. In conclusion, the Tealive Jalan University One can use this research to improve workflow process of making drink and foods. It will help to minimize idle time, reduce bottlenecks, and improve overall efficiency. Okay, okay, that's all from our group. Thank you.